So, hey everyone, welcome to the Cloud Native and Platform Engineering Meetup. I'm Ahmed, and as Chris said, am I in the frame?
Yeah.
Sweet as. Yeah, so I am a Microsoft Azure MVP, and what that basically means is like an award for people sharing content around Microsoft Azure. I'm a cloud solution architect, consultant, content creator, whatever. And I do put content on my blog. It's IA Max, and then on my YouTube channel, and this is my Twitter handle. And we actually have a clicker, which is super cool. Yeah. And I forgot to say, of course, I used to be a network architect for like 10 years of my life. So I worked for the good, when I first graduated from uni, 2005, back in Baghdad, Iraq, for telecom companies. So at that time, right after 2003, we were like just building telecom everywhere in the country. And I was really fortunate to be one of the first people to be part of that. So basically, you start with 4-5 Cisco routers, and then you end up with 60, 70 routers, and you learn that quite quickly is that whatever technology you're using doesn't scale, so you need to learn quickly on your feet. So yeah, so basically what I'm trying to say is that spent a good time of my life before jumping into the world of cloud computing and Kubernetes, doing a lot of networking, and of course that Cilium, and I'll talk more about what Cilium is. And the whole networking is a very big passion of mine, so I'd love to learn more about that technology. So what basically I'll be talking about today is how to do networking using a technology called CNI plugin. And Cilium is just one of the Cloud Native projects, Cloud Native Foundation project. There's a lot other CNI, but I like Cilium the most, and I'll talk more about the reasons. Yeah, so actually before I jump into what Cilium is and before I talk about the CNI, I thought that I needed to first set some ground rules about, and of course, feel free to stop me at any time and ask questions. You don't have to wait for me to finish. So the first thing that I want to talk about here is that what actually was striking for me when I first jumped into the world of, are you able to see it? Or?
That's good.
Okay, good. Yeah, so the first thing is that I was surprised that actually Kubernetes does not do networking by default. And I was like, that's very interesting. So they actually created something called container network interface specification. And then what that basically means is that they offloaded the job of networking to other projects. And they call those projects a plugin. So basically, the specification of Kubernetes is all about orchestration and efficiently running your containers. But for the networking, they offloaded that to the CNI specification. So that basically means that if you want to have any type of connectivity between within your Kubernetes cluster, outside of the cluster, you need to use a CNI. By default, a lot of cloud providers provide you with the CNI out of the box. Azure, AWS, Google, they have their own default, and I'm pretty sure all proprietary CNI plugins. And then, of course, the on-premises are like even Kubernetes in Docker. And by the way, if you spot any mistake, please tell me. If you think that if there's something wrong here, please stop me and say maybe that's not right. And so for any networking, you need a CNI plugin. The other thing that I found interesting is that within Kubernetes, the pod is the basic communication model. So like when we are talking about CNI plugins and when talking about networking, it's all about a pod talking to another pod. So there is the node, which is the virtual machine where you run your pods on top of. they don't care about that. It's not they don't care, it's the responsibility of the cloud and the platform provider. If it's a Azure, AWS, or Google, they should be providing you with the underlying networking. So that's outside of the concern of any CNI. And then there is the concept of a flat or non-hierarchical network. And in a second, I'll show you this diagram to explain more about what I just said to drive the point home. But I'm just trying to give you an idea of what the networking model within Kubernetes is. So what I mean by a flat and non-hierarchical network is that basically every pod within your cluster have an IP from the same virtual network. So every pod should be able to talk to every other pod directly. So it normally when you have a network, you have some devices part of a network, and then other devices part of, say, like a marketing network, and then HR network. And then those guys, if they want to talk to each other, they go through firewall, router, whatever we call them. This is a hierarchical type of networking. Within the cluster, so that developers and people, operation people, when they want to build on top of Kubernetes, the idea is that they don't need to care about this. Your pod is, as soon as you have your pod in the cluster, it should be able to talk to any other pod, okay? And then finally, no NAT. So you don't, in a CNI, you should not use any NATing because NATing complicates stuff. You are, as a cloud provider, you will be using NATing. If you want to connect multiple data centers, that's different, but within the cluster, you should not be using NATing. So this is just a basic diagram to show you the ideas that I was just talking about. So basically, this is the physical network, right? And these are the nodes. And in this diagram, we have 4 pods. And these 2 pods are running on this node, and these 2 pods are running on node 1. So these 2 nodes, they could be in the same data center. They could be in different data centers. This could be on the cloud. This could be on premises. It doesn't matter. Physical networking is outside the care of a Kubernetes network or a CNI specification. This is taken care of by whoever is building that network. Okay? So whether it's Microsoft, Amazon, or Google, on premises, whoever is providing the underlying network, they take care of this. Okay? In here, we've got something called an overlay network. That's where the magic happens. So the overlay network basically is just a way of tricking, I should say, or like a way of giving the illusion to these pods that they are part of the same network. So what this overlay is doing is that all these devices here, all these pods here, as you can see here, so like this is 10.1, 10.10.10, 10.10.1.10.20.30.40, part of the same network. If we are assuming A/24, and is so like the terminology that I'm using, is it like, do you guys understand like in like a subnet, and or is it too complicated? I could explain more about that. Is that all good? Sweet. Okay. Right. So basically, the illusion here is that the CNI, what it does actually behind the scene, and this is something that I learned from my telecom mold, is that it encapsulates so you've got a packet with an address and a source address, destination address, whatever it is. So what it does is that it encapsulates the packet with another packet, and that whole layer is hidden. And when you send it, say, from node 1 to node 2, you are using the outside package. So the outside package saying, oh, sorry. So you want to send a packet from here to the US. That's the outside package. When it reaches the data center within the US, they unwrap that packet, and now they look at the address on the inside packet. That inside packet gives this pod the illusion, even though, say, that this is in New Zealand and this is in the United States, they are on the same network. All right? So that's what basically this overlay network is doing. And within the pod containers talk to each other using something called the local host, which means basically they are like two processes on the same machine. They just talk to each other without thinking about networking. So it's almost like using the Linux networking specifications. And again, this is outside of the CNI. Is that good? Should I? Okay. All right. So the other thing that I want to talk about is a network policy. So we just started by saying that in a Kubernetes networking model, we have a permissive model. What that means is that every pod should be able to talk to every other pod. But what if you have a sensitive pod that contains some application or some database or whatever it is that you don't want every other pod to actually just easily talk to, right? That's when you start to have, you need to enforce some type of security or a network policy saying like, okay, so if you are a front-end pod, you are talking to a back-end pod, it's okay, you could talk, but you could only use port, TCP port 80, which basically is the HTTP protocol. That's what the network policy is doing, which is very similar if you're coming from a traditional networking world. The network policy is just similar. The difference here is that when I say cluster-wide application, so like say that you have 10, 20 pods in a cluster, right? In a networking world, in my mind, so like if you're trying to apply a security, you would need to apply it on a device by device. Say like, okay, this device is allowed to talk to this device. So they need a network policy per device almost. But in, sorry, I had a, yep. Yeah, so what I'm saying here is that the network policy is almost like a cluster-wide network policy. What I mean by that is that you could have one network policy to apply on all these pods. You could have multiple layers of complexity, that's okay, but you could use one network policy to rule them all. So that's the other rule. And then finally, you select a pod by using a, you could use a label, you could use an IP, but basically what that means is that when you create a pod, you give it a label, and then you start to say like, okay, this pod is allowed to talk, front-end pod talk to back-end pod, and so on and so forth. That's how you enforce the policy. And then finally, the implicit deny, which basically means if I'm not specifically saying this traffic is allowed, then every other traffic is denied. And I'll show you an example policy here. So this is just a YAML file that is our network policy. So basically, that's the name of the policy. It's kind network policy, that's the name. And in here, this is the specification of the policy. So what we are saying here, we are selecting a pod with a label that is backend. So now we are telling the CNI plugin is that if you've got a pod with the label backend, this policy is going to apply to. And if the pod, if it's getting traffic, which is the ingress here, ingress is a terminology, means traffic coming in to the pod, and egress is the traffic going out of the pod. So basically what I'm saying here, we have a pod called backend, use that label. If the traffic coming into that pod, it should be allowed if it has a label of a front end, and if it is targeting TCP port 80. So that basically means that's the only traffic that's allowed, okay? So even if the front end is sending traffic to say port 443, which is HTTPS, the secure HTTP, it's gonna be blocked. That's the rule of implicit deny. So if you are not explicitly saying this traffic is allowed, every other traffic is gonna be denied, okay? What also is surprising to me is that every other pod within that cluster is not going to have anything change. They all continue talking to each other, and even this pod would be sending traffic, egress traffic, okay, normally without being affected. It's only when you apply the policy that the permissive model of all talks to all is changing and becomes what is explicitly allowed, and everything else is implicitly denied. Okay? Is that good? Any questions? Cool. All right. And yeah, so this is what we just talked about. So this, the network policy is filtering traffic between pods. So, and also the network policy could filter traffic coming into the cluster and outside of the cluster. So in the network policy, you could say, oh, I forgot to mention one other thing, is that normally in a firewall or like in even a router, when you put a network policy, you actually specify the IP. You could say like, okay, source IP, destination IP, source port, destination port, allow or deny, okay? But in Kubernetes, because the pods are ephemeral, so like they spin up and then they, so like you spin up the pod and then you kill it if the pod is no longer needed. So this IP is changing so frequently. So it's very hard for you to keep track of which pod has got which IP if you are creating a network policy. So instead, you actually match by the label. So you just say like, actually, I don't care what's the IP address of this pod. It's just matched by the label. No matter what is what IP it gets assigned, if it got this label, then the policy applies to it. But for external traffic, you need to have an IP. So like if you're sending traffic outside of the cluster, traffic from outside the cluster into the cluster, that's when you use IP, and the network policy does also give you the possibility, the option, sorry, I should say, to say specific IP with this specific port should be allowed to talk to the cluster. All right, so now we get to talk about eBPF. So the idea is that what I'm trying to say here, we first talked about the Kubernetes networking in general, how is it different from traditional networking. And then we talked about the network policy, which is how is it, again, different from traditional network policy, what happens behind the scenes when we are applying a network policy on a cluster. And before I could start to talk about Cilium, I need to talk about eBPF because actually behind the scenes, Cilium is built on top of eBPF. So it's the technology that is powering that's powering Cilium, and I think I'm not 100% sure, but I think it's the only CNI that's actually built from the design to use eBPF. There are other tools that actually use eBPF, and there's actually even more and more tools that are using eBPF, and I'll talk about what eBPF in a second. But Cilium is like the different because it was built from the day one using eBPF. And I'm pretty sure some of the maintainers of eBPF actually work within Cilium. And Cilium is maintained by a company called Isovalent. And they've been doing a really good job and being very popular within CNI world. And they've been recently bought by Cisco, so they're doing really well for themselves. So, yeah. Right. So eBPF is actually based on an older technology called Berkeley packet filter. So it was just a technology to filter traffic within the kernel. So that's the magic of the eBPF. So within Linux kernel, you've got I would say a runtime. They actually filter traffic. And so what the eBPF guys came and they wanted to work and build a technology similar to eBPF, but because it was super difficult to actually change, because if each time you need to change that technology, you are playing with the source code of Linux. And as we know, the world running on Linux, and it's super hard to actually get everybody to agree on what to change. So they went in with the idea of like, okay, let's change the technology that has been used, which is BPF. They extended the functionality of it. Before it was like just basic filtering, and now they call it's like a lexicon or language of the runtime. It's way much more flexible now. You can match more than just basic filtering that it was. And it gave those three benefits. It's better performance, enhanced safety, and improved visibility. And the reason for that is that eBPF is actually, it's a sandbox that you run within the Linux kernel. So for the lack of a better analogy, unfortunately, I would say it's like a virtual machine. It's not a virtual machine, okay? It's a sandbox that you run within the kernel. And what that means is that it's isolated, it's safe. So before you run any program within the eBPF, there is a security check that it's not going to run forever. It needs to be secure before you actually execute the code. So that's the first thing. That's why it's improved security. Because also it's running within the kernel, it is really low overhead and very high performance because it's almost touching the hardware, right? And the other thing is that if I could show the next slide maybe. Yeah, so basically this is a slide from ebpf.io. So what provided us with is better networking security and observability. And this is what is called the user space. So the user space is where you run all your program, whatever type of program, it's called user space. And then this is the kernel. The kernel is the software touching the hardware, right? And this is sacred. It's very hard to actually change the source code of it. So what eBPF is doing is that it's integrated into the old BPF, extended that, and whatever type of SDK you want to build on top of. So the idea is that where is the right word? Compiled to bytecode. And that is like basically the language of the hardware. But because that is really hard to program with, so you could use Rust, Go, C++, whatever language to run what is basically called an eBPF program. And those eBPF program or application, those could be things like Falco, which is a security tool, an observability tool. It's the Cilium, the hero of our story today, and multiple other projects that actually build on top of eBPF. Right. So that basically gives us a very good idea why Cilium is really successful, is that they are using this very popular technology that is now basically allowing you to plug in and extend the kernel. So like you want to have, before it was just networking, now you could use eBPF even for storage, and a lot more technology is building on top of this eBPF because it's starting to become like a way to extend the functionality of the kernel. And I was actually so tempted to, and I was looked it up, and I was like, is WebAssembly using eBPF? And apparently it's not. A WebAssembly, Todd, right? Yeah. Todd is going to tell us more about it just now. It's basically used to just live in the web browser. It now starting to work in the server side, but there are some talks about integration between WebAssembly and eBPF. So it's really cool, and it's a very cool technology. Any questions? And so go. Right. It's a very long introduction to talk about Cilium, but I thought that was useful and helpful for us to actually understand what's the big deal about Cilium. So basically, because Cilium is powered by eBPF, it's built on top of this new technology, and because of eBPF, it's actually really high performance and low overhead, and actually one of the selling points on why would you want to use a tool like Cilium as opposed to just go with the native CNI that AWS, Azure, and Google guys would provide you with, is that if you're really looking for high performance, then Cilium is the way to go. And again, because of the advanced security of eBPF, and so the tool itself, is really easy to use and really successful. It's building on, I don't want to just give all the credit to eBPF. So yes, it's building on eBPF, but they also are providing a lot more security. I listened to a talk recently with their founder, and his vision is actually Cilium everywhere. So they're thinking of having Cilium to connect multiple clouds, Cilium connecting your hybrid cloud from on-prem to the cloud. And they've been supporting a lot of technology to help them with that. So right now, for example, it's a while now they support BGP. So BGP is basically the protocol that is running the internet, okay? So what they're trying to do is that they want to have one tool. If you have multiple environments, it's just one tool to do all your networking, okay? And again, detailed observability, and we talked about cross-platform. Because it's using eBPF, it's actually within the kernel. So any system call, any network event, whatever type of activity that goes between the kernel to the user space, eBPF is actually able to catch it, and with low overhead. So that actually gives you really high resolution on what is going on within your environment, and you could go really fine-tune to understand all the activities within your kernel, within your networking and Kubernetes cluster. Yeah, so this is basically what I was talking about. Basically, this is, maybe it's not shown really well. This is basically the Cilium layer. Okay, this is orchestration, which is Kubernetes in this case. This is the Cilium daemon. That's the bytecode injection. So whether it's a container, it's an Ethernet 0 interface, it talks to those to the containers and to the Ethernet using BPF programs. And of course, you've got the CLI, you've got your policy repo, you've got other plugins to the CNI plugin, which is ironic. And of course, you've got the Cilium monitor. You actually could get a GUI to literally plug and play your network policy to visualize what is it that you're trying to do, as opposed to just running that within creating network policies. All right. So what I'm going to do here today, it is actually applicable to any other Kubernetes cluster. In this case, I'm familiar with Azure Kubernetes, but you could run it on any other AKS, GKE, whatever other type of Kubernetes. It's called Star Wars Demo. Cilium guys created it. It's basically an idea of, so this is the idea, okay? So I'm not going to go through the analogy because maybe I'm not the most expert here. But what basically is here is that you've got two types of labels. So you've got the Death Star, which is represent a type of service that you don't want anybody to have access to. And then you've got TIE fighters and then X-Wings. So basically, the TIE fighter is part of the Empire. So you will have a policy saying like, okay, if this pod is coming from a label of the Empire, so then it's allowed to talk to the Death Star. Any other type of organization, it's not allowed. So what we'll do is that we'll create a network policy saying, basically matching traffic on from a TIE fighter to a Death Star with a TCP 80 is allowed, everything else is denied. And this is the policy. So the policy is saying that for the, in here you find the Cilium, they changed the network policy terminology. So when we said port selector, they call it endpoint selector. It's because they provide more sophisticated than the default network policy by Kubernetes. Match label org Empire and then class Death Star. That means that this policy is going to now apply on this service. If the traffic ingress coming from an endpoint with the org Empire, suite as allowed on port 80. So that basically means this guy will be allowed to talk to the this service. This one does not have the org Empire. It's going to be denied. This is what is called now a layer 4. This is a networking terminology. So in networking, you've got 7 layers. You've got the layer 1, which is cables and Ethernet and fiber cables. Layer 2, layer 3, where you have your IP addresses. Layer 4, where you have TCP UDP protocol, all the way to layer 7, where you have HTTP protocol. So this is called a layer 4 network policy. Next, we'll try to even have more security, which is even though TIE fighters are allowed to talk to Death Star, they're having the possibility, which is again just extending the analogy, is that maybe they should not be allowed to talk to the exhaust port because that's an so you allow it on layer 4 TCP or 80 HTTP protocol, but maybe you don't want to expose all your APIs. Okay, so this API should be blocked. Only authorized resources should talk to it. So now you're going to say TCP port 80 is allowed. If you're talking to request landing, then you're allowed. Any other type of request is denied. And this is the policy for it. Basically same as the one before, just adding this method now. So again, this policy is applying to the Death Star. If you are org empire talking over port 80, you are allowed. But now you are only allowed to use the HTTP post request landing. Okay? And yeah, that's about it. And now, hopefully, the demo gods are going to work for us. So I've already prepared created a Kubernetes cluster on Azure. And I actually have everything that I said here is actually on my blog. I have 4 posts where I talk, blog post articles where I talk. Let me show you. All right. So this blog post goes deep into this is the last one, the number 4. It talks into deep details of what the concept, the details, and the method that I followed, and even the code. So if you don't have an Azure cluster, you could just build one using this Azure CLI. And then you need to have your credentials so that you could manage it using Kubernetes CLI from your command line. So I was actually doing all that before you guys joined in. So this was me creating the cluster. And yeah, so I know this is recorded. I'm not going to show all the details. Yeah. So basically what I did is that I created the Kubernetes cluster. I installed Cilium using what is called Cilium CLI. So because I'm using Mac, to install the Cilium CLI, you just say brew install Cilium CLI and installs it for you. And so basically, if we say,
can you increase the font size?
Yep, sorry. So I don't know how to do that. So wait a second. Let me see if it's Command plus, maybe. Yep. Is it good? Yep, just a second. Is it good now? Yeah. So basically, this just tells us that Cilium is running, and if you say so this is our cluster. It's just one node. It doesn't need to be more. It's just a node that I spin up on Azure. And what I'm going to do now is the first thing I'm going to do is actually install the application, or like provision the application on the cluster. Actually, I think I've already done that. But for the code for that is So the code for that is on GitHub, and it is part of the it's a Cilium application, so it's part of their Cilium GitHub repo. So you just grab it from the repo by running the kubectl create file, and then you put the URL for it, and it grabs the code and then installs it on your Kubernetes cluster. So what we are going to do is actually the first thing before applying any policy is that we need to check if it is going to work. So what this is going to do is that it's simulating a request to the service. So like if you paste it here, this is the X-Wing. Before any type of policy, it just says ship landed. Okay. If we take the other one, the TIE fighter, again, apply it here, it should say the ship landed. Okay. So, go ahead.
Did you remove the Azure CNI from this, or it's?
Yes, I did. Yeah, that's a very good question. It's a very good question. Actually, there are two steps that I forgot to mention. So when you try to enable Cilium CNI, you need to disable the Azure CNI first. So what I did is that when I created the cluster, I created it without a CNI because it takes very long time to disable the original CNI. I'm just looking for the code that I used to create the cluster.
I think in AWS it's different story. You can install Cilium with the using AWS CNI as well. You don't need to remove it. Definitely with Calico, I'm not sure about Selenium.
Right. Yeah. So.
And what's the reason again that you install Cilium? It's because you use network policy? Or eBPF you can achieve by using Falco.
Yeah, Falco is not. I think Falco is not a CNI. Falco is more of a security.
No, it's not a CNI. It's a security.
Yeah.
That's
That's right.
Basically, you can create your custom rule. For example, if someone SSH into the pod, into the container, Falco can. I'm here. I'm not here to sell you. I'm just telling you the possibilities. I like it because it's easier for me to understand and use. And I also like Falco. Funny enough is that, if you see here, so there are multiple. If you go to the landscape, it's too hard. There are so many tools that does the same thing. So many tools actually build and integrate on each other. Behind the scenes, Cilium actually use Istio, they use Calico, they use so many other technologies. They don't claim the fame for everything, right? Yeah, so, of course. So, but your question is right. When I created, I said like network plugin none, because what I've done before is that you create the cluster without specifying what to do with the CNI. When you try to install the CNI, it's going to give you an error saying like there's already a CNI, you need to disable it first. So you disable it and it takes forever. And then sometimes it actually fails because when you create the cluster, it assumes a lot of stuff because you're saying use the default Azure CNI. When you say don't use that, it is so much more. So might as well create the cluster without a CNI first. And then, of course, if it's a production, you could do all the steps and it's like AKS update, blah, blah, blah. But you need to have a downtime, okay? But yeah, your question is right. Yeah, I asked because in AKS, for example, AWS Kubernetes, we used to install the Calico.
Yeah.
Because there was no network policy feature.
Yep.
Now AWS allows it, so Calico is not required. Unless you want to replace the whole CNI, then you need to install Calico Cilium, and then you manage all the network by yourself. I don't know, like when I'm reading on document, on paper, we are saying like Cilium is better, provide more advanced security than the native Azure or whatever native tool. The issue is that if you live in AWS world, if you live in Azure world, it makes total sense. It's more integrated into the ecosystem and the platform, much easier actually. So for example, if you want to access another service within Kubernetes, you don't, if it's using Azure CNI, you don't think about it. But if it's Cilium, it was like, okay, let's first allow Cilium to talk to this and talk to that. It's much difficult. But if you have multiple clouds and if there is a killer feature, say like you really want performance or whatever, and then that is not available within Azure CNI, AKS, native CNI, GKE, you use the Cilium one. And of course, it could be Falco, it could be Calico, whatever type. For me personally, when I first started learning, I used Flannel because it was super easy to install. When you use Cilium, you need to make sure that there is an eBPF. So what I was doing is that I had a Windows subsystem for Linux. I was like, okay, using that. And then when I installed Cilium, it gave me so many errors because apparently I think the Linux provided within Windows sub Linux does not have eBPF, so I have to install it. So I gave up on it. I would jump in on the Mac. So so anyway, basically, right now there's no network policy. We're just using the native, default model of all is allowed to all. Okay. Does AKS have a network policy? I'm not that familiar with AKS.
It does. Yeah. But again, if you're looking for extra features, if you're looking for something specific, I'm not really sure what is Azure CNI built on top of. So like, is it completely proprietary? Are you using proprietary, are building on top of another open source technology? Not really sure, right? But it's well integrated within the ecosystem and it's production ready, people using it. So again, I'm not selling you Cilium or Azure CNI. it's just a new technology, good to know about, and there is the option to use it. Yeah. Yeah. So the next step is to actually block level 4 type of traffic. So what to do that? What we'll do is that we'll need to grab the network policy here, and it's again on a GitHub repo. And of course, we need to pray for the demo gods that it would work. Fingers crossed. Okay, so now the policy is working. The TIE fighter should say ship landed. The X-wing guy should time out. Yeah, so that's good. It's going to take a while to time out, so I'll stop it. But basically what that means is that because the TIE fighter, the X-wing, if we go back to the slides, maybe. Yep, so because, where is it? This guy. So because this guy is using the org alliance, so it does not match, it's not allowed to talk to the org empire. So because the policy was, so this is the policy that I just applied. The policy is saying if the traffic coming in to the service Death Star from an org empire on port 80, suite as apply, allow. Anything else is implicitly denied. Okay. The next step is we need to now apply this policy, which is to not only block TCP traffic coming in from any other source beside the org alliance, even within the org empire, if the traffic is going to anywhere else beside request landing, exhaust port or whatever, it's going to fail. Okay. So for that, we need to apply this policy, which is basically, again, exact simple policy, but with only one addition, is that another rule saying if anything beside a post to this path, anything is to this path is allowed, anything else should be denied. So fingers crossed again that this should work. All right, so this is the policy here. And as you can see, it's still trying to do something, so it's timing out. So we now pulled in the next policy, the layer 7 policy, again from the GitHub repo, and it says configured. So the first, this one, the TIE fighter, because it's going to request landing, nothing changed, should say ship landed. The X-wing should still be denied. Okay. Yeah, it's denied, it's going to time out. The last thing that we want to try is to use the TIE fighter, which was allowed to talk to request landing, but now the code should say exhaust port. Okay, so this is basically not explicitly allowed, so it's implicitly denied. So what's going to happen here, and fingers crossed it works, access denied. Woohoo! Yeah, so that's basically it. That's the whole demo. And yeah, do you guys have any questions?
Do you have any monitoring tool to see what happens at the packet level?
Yeah, that's a very good question. Actually, they provide something called Hubble, Cilium guys. So it's a plugin. It's another tool that they have. So when you install Cilium, you have the option of, actually, very good question. So Cilium status. Yeah, so in here, it says the Hubble relay is disabled, okay? So it's a, of course the name is, the reference is obvious. The idea is that so what Cilium guys are selling us is networking, security, observability. That's what they're selling, okay? They're not pretending to provide service mesh type of functionality. They're not pretending to provide anything else. They're selling these three domains, networking, security, and observability. So if you install Hubble within Cilium, you could actually have to know like what is going on behind the scenes. My knowledge about Hubble is really just like I'm just beginning to understand it. And I'm not claiming I'm an expert on Cilium, but yes. Yep.
So is this like a policy manager?
It's a very good question. So actually so like a lot of CNI plugins, they just provide you with the networking. So if you're running, for example, Kubernetes in Docker, that's called kind, which is basically a way of running a cluster on your machine using Docker desktop. So that comes with something, if I'm not mistaken, called KubeNet or whatever. So that's a CNI provided within the software Docker desktop. So the idea is that this provides you with networking. But if you want to apply any type of security, it's not going to help you with that. So basically, yes, if you're running with code with using YAML files and everything, yep, you could do that. But they have also got a GUI. So actually, they've got something really cool. I don't know if I could find it, which is Isovalent Labs. So you could basically run the whole thing that I just took you through using their own lab. It's for free. Okay, I think it's this one. Is it this one, the first one? No, this one, I think. Yep. So you basically just like sign up and then start the lab. They'll give you a lab environment. And then within that lab environment, you actually get access to the network policy graphical user interface. It's really cool. It's actually you just grab a block and then put it in here. Say like, okay, this policy is on this label, on this pod. It's allowing it to do blah, 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 and then so on and so forth. It is, what they're selling it is that for operators, for network engineers and all that, it's really hard to actually visualize what is going on within the cluster. So instead, they give you this GUI to do all that. Yep. Does that answer your question? Sweet.
Can I also do layer 7 filter for HTTPS?
Yeah, of course. Yeah. It's just block it on. Oh, okay. I get it. I get your point. As in, like, is it gonna open up the packet and then? It actually do provide TLS encryption. They provide data path encryption. I don't know if they block the HTTPS traffic. I thought you were talking about the layer 4.
No,
but
you have this layer 7 policy, and I understand this is ultimate selling point because no one else does layer 7 and filtering in. This is why they have their own format for network policies, not using Kubernetes network policies.
So if we go back, actually, that's a very good question, and let me think through it. Okay. So if we go back to this policy, okay, and then go back to layer 7, and again, I'm just thinking through it with you. I think the slide is wrong here. It should say layer 7. Okay. So okay, so the policy is saying it's TCP port, TCP traffic going to port 80. So if it's HTTPS, it's TCP 443.
No, you can't make this assumption. Not in network policy engine. You can't say that port number matches protocol. It's like no.
What do you mean?
They wouldn't make this assumption because we run HTTP stuff on all kind of ports and HTTPS on all kind of ports.
I get it. But if you are...
it says rules HTTP. Yeah, here.
Yeah, I understand. Yeah, but if you are the one who's providing the service, you know which port it is. You don't have to... You're not blocking traffic to a external destination. You are protecting your own service. So if you are using port 8080, right, you could say 8080 is blocked. If you are for HTTPS, 443 is the default one. If you are using something else, then say 443 and then say you're not allowed to talk to this.
The protocol is right there in the rules. Rules HTTP, that's protocol. The question now, can you have rules HTTPS?
I think by assumption, I'm not really sure, but if you, the protocol, this does not mean, when you say HTTP, it does not mean it's gonna say match HTTP. This is what is HTTP. So this is TCP port 80. This is the HTTP part of it.
It is very
Because HTTP in the end, it's a networking protocol. It needs to have a source destination port. It doesn't, yes, there is deep packet inspection. If there is a hidden type of protocol within HTTP, you could actually catch it. But basically, if you want to talk on using HTTP protocol, you need a TCP source and port and destination.
If you run Kate proxy, its default port is 8.0.1.
Okay.
Right, it's TCP port, it's HTTP protocol, it's a different port, not 8.0.1. It wouldn't know, like if you plug it here, it wouldn't know that this port matches to HTTP. Like you can't make assumption that port number matches protocol, because port is level 4, protocol is level 7. You can't just make assumption. But here you don't need to make assumption. It specifically says there is a protocol HTTP in the port 80. It's good. Okay, I see it. Now it's only question, like, can they actually look inside the HTTPS packet? That would be like, wow.
Yeah, I would say maybe Google it or like look it up. But in my mind, and I could be mistaken, in the end it's a YAML file, and of course you use their own language. But in my mind, any networking protocol needs to have a source and destination. And if you are protecting your resources, you should know which port is blocked. So like, you're protecting your resources, you say like port 4000 whatever. This is the port is allowed. If Ahmed or someone else should be talking to it, he needs to talk to this port, using this protocol, on this API. He's okay. Everything else is not. And again, I'm not claiming to be an expert in Cilium. There is so much more. It's a bigger ecosystem than just.
No, yeah, I understand what you're saying. So you're running something in port 80, and you want to allow only, not just any HTTP packet in the port 80. You want to allow only one URL. The question is now, you know that this is for port 80, but how do you check against URL? It requires knowing the protocol. Because like if you're looking at in HTTPS, there is a different way to examine the URL.
Yeah.
It's in a different place in the packet.
Yeah, you're right. Again, like I said, this is, you could go through the rules and you could check exactly what do they have under HTTP and HTTPS and what type of methods they allow or they don't. Yeah.
Have you tried any AI tool to use to create network policy with Cilium? You can create network policies and even Falco rules with AI today.
Yeah, you could, of course, but the issue is, as with any type of Gen AI, is that you need to validate the code yourself.
Yeah, sure.
The issue is that, so for example, there are like literally terabytes and gigabytes of JSON and YAML files that could just like hoover it into the Gen AI and it could figure out what is going on behind the scene. But even with any type of Gen AI, you grab the code, you put it in the on the test, and it's like, oh, sorry, I forgot there's another space, or I forgot there's a whatever. And the issue is there are two things. The things that there's a knowledge cut, right? So if things change after the AI was trained, it's not going to know about it. And then there is the other thing, is that the AI only knows about what it knows, right? So like maybe it got access to this side of the internet and not the other side. So I would not know everything. So I've used GitHub Copilot. The Copilot part of it is amazing. GitHub Chat, meh, not so much, right? And then of course there is Claude AI, there is Meta AI, there is ChatGPT. They are all amazing, and everyone has got its own strength. Yeah, but of course, I would try it, because if I'm trying to learn something, like me looking at this is so much easier to figure out what is going on behind the scene than just like reading pages and pages. If you look, it's like, okay, this is the policy, this is what we're trying to do. Okay, I'm mostly completely butchered your time. So thank you everyone, and I hope you found this useful. And again, you could find me on on Twitter, and I've got my own blog. And yeah, thank you so much. Appreciate it.